Dimitri, Christian, and Neil for the opportunity to present here. And thanks to all of you for taking time out of your busy schedule and attending this presentation. So this is joint work with Antu Mai and Paola Pederzoli. I think they're both in the audience. And so if it's okay, if there are questions in the chat that are sort of that they feel like they should answer, they'll do that. And if you're not, if you want additional explanation, feel free to reply, and then we'll take it from there. And as Dima was saying, please feel free to ask questions. Okay, so what is this all about? This is about supply and demand in index option markets. So in a sense, it's good to sort of split up between supply and demand to highlight the contributions of this paper. So on the supply side, there has been this resurgence in interest in the role of intermediaries in securities markets, right? Mainly following the financial crisis, right? So it became clear that especially in over-the-counter markets, these intermediaries are very important. We have to study price pressures, et cetera, et cetera. We have to really understand what happens in a crisis, what the role is of these intermediaries. Okay. Now, in option markets and index option markets in particular, what that means is we're talking about market makers. Now, let me be very clear about this because it's an obvious question. Are market makers the only suppliers of liquidity in option markets? Of course not, right? We all know that. But because of the nature of the data that we use and that many other people have used, we're sort of identifying market makers as the suppliers of liquidity. And so basically as a supply curve here. I'll talk a little bit more about the data in a minute. This literature on supply in option markets actually goes back to before the financial crisis, and to the best of my knowledge, it starts with this really nice Bollen and Whaley paper, where basically they investigate the Black-Scholes hypothesis of an infinitely elastic supply curve, and so from several papers listed there, amongst others, Bollen and Whaley, Garliano, Dimitri's paper, I think there's consensus that the supply curve is upward sloping, that null hypothesis is rejected. So where we contribute in this literature is that we basically make the simple observation that what we call net demand in these data is really not the demand curve, but it is equilibrium demand. And so you run into the argument that we all learned in one of our first economics courses, which is that you have a demand curve, you have a supply curve, they shift around, and all we see is equilibrium prices and quantities. We just see a scatter plot, and then we can make identifying assumptions as to what whether the demand curve doesn't shift a lot or the supply curve doesn't shift a lot. But ideally, we would like to try to use that scatter plot to identify demand and supply. And that's what we do here. And so fortunately, we have a tool at our disposal that we think can help us with that. So that's on the supply side, what we're interested in. On the demand side, it's sort of a little bit fortuitous for us, I guess, that while we were working on this demand system approach to asset pricing, which is sort of associated with names like Koyen and Yogo, has been really taking off. And so there's this again renewed interest in demand curves and demand elasticities. And so from that perspective, what do we really know about investor demand in option markets? Maybe it's fair to say not a whole lot. And so to the extent that we can identify supply and demand, and of course that's not simple, I'm the first to admit that, we can say something interesting about that. So what we're going to do with respect to this literature in the end is very simple, that I'm going to show you some estimates of elasticities of the supply curve and the demand curve, and to the extent that you buy how we get those, then in principle you can compare those numbers to the ones that Ralph gets in his papers. And interestingly, what we get using a very different, so I have to disappoint maybe some people, we use very different methods, right? So we're going to use very different methods, very different types of data, but actually the numbers that we're getting are sort of roughly in line with some of the findings in that literature. All right, so how are we going to proceed? We're going to try to contribute to these two literatures, bridge these two literatures if you want, by using a technique which is maybe not that well known yet to many of you. We're going to basically estimate the demand and the supply curve, so the economics or econometrics 101 problem, and we're going to go back to a technique that was so the can you all see my cursor moving? So the name we have up here is Uhlig. That's because Harold wrote this overview paper on the topic, made some really important contributions to it, but there's a lot of people who have contributed to that literature early on, and there's literally hundreds of papers that have used this in the macroeconomics and macroeconometrics literature. So basically, this is just, you're going to estimate vector autoregressions, right? And then what you're going to do in the vector autoregression is that you're going to deal with the endogeneity of price and quantity by imposing very simple sign restrictions. So what we want to do is we want to impose as few restrictions as possible. All right. In the case that I don't finish, let me give you a very brief overview of what we find. So we estimate this system of demand and supply equations, like I just said. Okay, and what do we do? Well, once we do that, now we can identify latent demand and supply. So now you can sort of look at the time series properties of latent demand and supply, and you can also compare it, for instance, to the equilibrium demand that I mentioned earlier. And so what we find is very clearly latent demand does not look anything like the equilibrium demand. So that is basically illustrating the endogeneity problem. Once you have latent demand and supply, here's a very simple exercise you can do, which obviously we do, is you take the time series that comes out of the VAR, and you just regress it on things that you think might be shifters of demand and supply. And so that's exactly what we're going to do. We're going to regress latent demand and supply on all kinds of measures of risk that we think are going to shift demand and supply. And I'm going to tell you, it's a very clear pattern that we observe. And the pattern is that when risk is high, demand for options shifts to the right and supply shifts to the left. So let me just stop there for a second, because I don't know what your priors were. So I'll tell you what my priors were. My prior was very clear on the supply that would shift to the left. You know, with respect to the demand, my prior was a lot less clear. And I guess it was more, my prior was more that what demand was going to do would depend a lot more on the particular market, meaning calls versus puts, at the money versus out of the money. And that's not what we see. We see a very clear pattern that when risk is high, supply shifts left, demand shifts right. All right. So what else are we going to do? I'm going to show you some results where if you identify these shifts in demand and supply, you can use them to predict future option returns and the future market returns. So here we're using index options, so we're talking about the S&P 500 return. Now, I have to warn you, the R square of these predictive regressions is not large. It's in the order of 3%, but as we all know, 3% is not a bad out of sample R square. I'm going to also show you results that suggest, pretty much in line with my prior, that the at the money market and the out of the money markets are quite different, in the sense that the at the money market is more demand driven, whereas the out of the money market is more supply driven. So this is a very easy analysis to do just as a byproduct of what you get from estimating the VAR. And then finally, and so for some people, maybe some people would say this is probably the main point of interest in the paper. I think it's a point of interest. So finally, we can look at the price impact of a trade. And that is, of course, a very important topic that many people have studied. So what's the price impact of a trade? How elastic is supply? How elastic is demand? And one byproduct of that analysis is that if you can look at that not just over the whole sample, but also in crises, and so we have two important crises in our data, which is the financial crisis, 2008, 2009, and then the COVID crisis. You can also see how market makers behave in the crisis. And so what we find, maybe, I don't know if it's controversial, but the elasticities that we find of the market maker supply are fairly large. They're well above 1, even during those crises. So that would be consistent with the view that these market makers continue to provide liquidity in crises. And that's maybe a little bit more controversial. I mean, I have to tell you, we'll get there in more detail, but what's large, what's small? Is above 1 large? That's a very legitimate question, I think. But nevertheless, we have to start somewhere. Okay, so here's the agenda. I'm going to zoom through this. I'm just going to talk a little bit about sign restricted VAR, because my guess is that many of you have not used that tool before. Very briefly talk about the data because we got a lot of questions about the data. Then I'm going to show you the results, and then I'm going to glance over the robustness results because I'm going to refer to the paper for that, but then I'm going to try to discuss some of the results. And this is sort of the discussion here is basically going to be me sort of answering what I would call frequently asked questions, FAQ, right? So these are, you know, we've presented this paper a number of times already, and there are questions that keep coming back. And so I want to basically address some of those, and then obviously any others that you might have. All right. Okay, so here we go. First, the sign restricted VAR. It's really, let me be clear. I was going to say it's really simple. It's not really simple. It's not simple in terms of estimation. So this is going to be done. We're going to estimate this VAR, sign restricted VAR, using a Bayesian approach. The estimation is simple, but the principle behind it is very simple, right? So what are we interested in? We're interested in price and quantity, and I'm gonna basically define. I'm going to basically tell you our definition of price and quantity in a minute, but very generally, it's price and quantity in this market, right? In the index option market. And so all we have here, so we have two variables of interest. So this is a very simple VAR as a function of the lags. We select the lags using the BIC, very standard. So now I have these errors here, UT. And so as we all know, in the vector, when you use vector autoregressions, the whole game is that you have to get these reduced form residuals and you have to map them into what we call the orthonormal fundamental shocks, or as I like to call them, the structural shocks, a little bit simpler, right? And so what's really important in this whole process is this matrix A that maps UT into epsilon T. Well, here it is. It couldn't be any simpler, right? So I have my two UTs here for price and quantity. I have my two epsilons here for supply and demand, right? And then I have my matrix A here, which is a 2 by 2. And all we're going to do in this sign restricted VAR is we're going to impose sign restrictions on how these shocks to supply and demand affect prices and quantities. And so, here it is. It's really, like I said, it's economics 101, right? So if you think about latent demand, right, the demand curve shifts, right? If it shifts to the right, it's going to increase equilibrium price and quantity. That's basically what those plus signs stand for. And then if you think about the shock to supply, if your supply curve shifts to the right, that means it's going to decrease equilibrium price and increase equilibrium quantity. So that's all. That's all these signs mean, right? So now you can think about this in two ways, and they're equivalent. One way is, well, econometrically, I have to map UT into epsilon T. And so the literature, we've been doing this for 60 years, 50, 60 years, something like that. Let's say 50 to be conservative. We've been doing this for a long time. And usually what we do is, remember, we order the variables, right? So that's the traditional way that we do this. We say this variable is more important or more exogenous than another variable. So I don't know about you, but I always find that difficult. Here, technically speaking, we address that issue of the mapping in a different way, which is just relying on these economic restrictions, which for me is preferable, right?
Can I jump in? Can I jump in? So there's a question in the chat. Mm-hmm. Can you provide more intuition or explanation regarding why these sign restrictions are enough to solve the endogeneity problem?
Why the sign restrictions? Yeah, so I can't really draw here, but I don't know if there's more to the question than I think. But just think of, we are basically given data, which is a scatter plot, right, of equilibrium prices and quantities, right? And then now what you're basically going to be saying is, if I look at that scatter plot and I want to trace out my supply and my demand curve, I'm basically just going to, looking at the data, I'm going to restrict what happens when the supply curve shifts to the right and when the demand curve shifts to the right, right? And that in itself it should be sufficient to solve the endogeneity problem, right? So maybe you're suggesting that, well, these things are shifting all over the place, right? And so how are you going to identify this in the end? Well, in the end, of course, it's going to be an empirical question whether, given these theoretical restrictions, we can precisely estimate, right? So, but that's a different issue. That's not really identification. That's just how precisely can we estimate these things, and that is an empirical question. But I think from my understanding, the way I understand it is, from an identification perspective, this is sufficient. I hope that answers the question. All right. Okay, so if you rewrite these equations, then of course you can see that your supply curve, price as a function of quantity, and your demand curve, price as a function of quantity, are simply a function of these coefficients, these 4 coefficients here in this A matrix. So that's all there is to it. Like I said, econometrically, in terms of estimating this, there's a lot of other things going on, but economically and in terms of the intuition for the approach, this is all there is to it.
Okay. So can I ask my own question now?
Yes. Mm-hmm.
So there are going to be infinitely many sets of AIJs that satisfy infinitely many AIJs that satisfy the sign restrictions. How do I pick among them?
Infinitely many AIJs.
There are infinitely many matrices A that satisfy the sign restriction.
Right, correct. This is set identified, right?
Yeah, it is set identified, if that's what you mean, Neil. Yes, that's correct. Right? Yeah. So this is set identified, and so there you. Okay, so I see where this question is going. Yeah. So this is a question which is I think fairly discussed in quite some detail in this macroeconomics, macroeconometrics literature. So you're absolutely right. It is set identified. Just to go in a little bit more detail then about this, the way we're going to so the answer is it lies in the way you're estimating this, right? And so the way we're going to estimate this is using a Bayesian procedure. In a Bayesian procedure, the way you tackle that problem is by basically in the message is going to lie in the message from the prior to the posterior. So basically, you're going to have a prior on these either the A11, A12, etc. coefficients themselves, or on some function of those. Right, and then what you're going to do is you're going to look at your prior, and you're going to look at your posterior, and you're going to see what message is in the data for the function of interest. Right, now we are working, in line with we're basically using a prior that's been used extensively in this literature, which is a non-informative prior, but you could basically use an informative prior too, and that's actually one of the things that we are, basically talking about right now, and that's definitely something that we could still do in the paper. I see several raised hands. Yeah, oh. Yep. Several.
Oh, go ahead, Ian.
So, the pitch that you've given, on some level, kind of, suggests that this couldn't possibly go wrong, which feels too strong, right? That like there must be a way for this to fail. And so I would imagine that it would be like misspecification, and there are at least 2 forms that I could think of. One would be heteroscedasticity in the shocks, and the other would be the A's changing over time, right? That presumably that would let, you're going to pick out a set of A's, but there's no reason I would think those would be constant, and you're going to have a covariance matrix, and there's no reason I would think that would be constant. And like the latter seems maybe especially worrisome, since this is all kind of identified off of variation and volatility. And so could you no, what do we need to believe for this to work?
Okay. If I gave the impression that this could not possibly go wrong, I apologize. Everything can go wrong, including this. And your intuition is exactly right, Ian. I mean, I think using these sign restrictions is very intuitive and simple, but you're absolutely right. Any inference that you get out of this is only going to be as good as a specification. To the extent that the specification is incorrect, you're going to run into trouble. Do we know? Do I have a good idea of how much trouble we could get in? No, in all honesty, not. Because what you would have to do there is you would have to run a Monte Carlo experiment where you, as you're suggesting, I think, you could generate data that are basically a deviation from these assumptions, and then see what you get. And you're absolutely right. Heteroscedasticity is definitely an interesting one. I'm gonna show you some results which in some ways, indirectly at least, have something to say about heteroscedasticity. But no, I cannot answer your question with certainty whether what we're doing is robust to all of those potential misspecification issues. That's fair. There was another.
Okay, sorry. One more, Stylianos.
Stylianos, yeah.
Yeah, hi. I don't have any comments about the econometrics. It's not my field, but I do have some comments about economics. I understand you said that the demand shocks are from the end users, and the supply shocks are from the market makers. Correct?
Yes.
Well, let me put it this way: do you have any idea how many market makers are, and whether this assumes automatically that there is some competition, if you like, perfect competition in both the end users, which is reasonable, but also in the market makers, which I beg to differ for reasons that I answer in the end, perhaps. But go ahead. What do you think about?
Yeah, so Stylianos, I don't know how familiar you are with the data that we're going to use, but I thought your question was going to go in another way as to why we're making that assumption. So that's a data-driven assumption. Now, in terms of the competition there, let's see, I could may get this wrong, but I think the market structure of both the demand and the supply, especially the supply side, obviously you're thinking, the market structure of the supply side, I do not think is going to impact much on what we're doing, unless I'm really missing something. So that, in other words, they could, market makers could be perfectly competitive or not. I'm not sure that changes our approach. There's just a supply curve out there with whatever market structure behind it that may be.
Well, okay, no, the price and quantity become endogenous. You see, they're both, if you like, choosing, if you have an oligopoly, for instance, which is the most plausible there in the market maker, then you have different conditions than to have independent shocks. See, it is, the shocks are also driven from, if you like, decisions and aggregate. Because for your information, I haven't looked at SPX, but I do know that there's one designated liquidity provider. Okay, and
let me jump in. Let me jump in and say, Stylianos, let's take that up at the end. We have to let Kris get to the main results.
I agree. Excuse me.
And then we'll have time for free discussion at the end.
All right.
Thank
it's a fair point, Stylianos.
I apologize.
I haven't thought about that enough. No, that's totally fine. All right. Very good. Thank you. All right. So let me briefly talk about the data, and that also maybe addresses some questions that other people might have about the role of the market maker in this whole analysis. All right. So we're going to use data from 1996 to 2020. These are daily data. Many of the pictures I'm going to show you are aggregated up to monthly, just to make it visually easier to look at. And then so here's one of the questions that we sometimes get. Our price proxy is simply going to be the daily change in the average implied volatility, right? And so now I know that you could use other price proxies. So some people say, why don't you use the variance risk premium, for instance, or why don't you do what Carliano, Penn and Pottishman do, which is implied volatility and deviation from some model. All of those are possible. We have some robustness analysis in the paper. The reason I like this is it's the cleanest. It's the cleanest because I'm tying my hands. It's just implied volatility. If I do VRP, I can implement it in 10 different ways. So I want to start with this, and then I want to do VRP as a robustness analysis. So that's our price proxy. Second, our quantity proxy. So this is the data that some of you are familiar with, but probably not everybody. These are the CBOE open close database data that have been used in several existing studies. And so what we basically get is at the daily frequency, the CBOE reports, right, the aggregated buys and sells from what they call end users. So the way to think about end users is it's everybody who's not a market maker. And so empirically, what you can work with is that they separate out market makers and non-market makers. And so to the extent that you're wondering, oh, is there, are market makers the only liquidity providers? Is liquidity provided by some of these end users? The answer is yes, that is the case. And there's absolutely nothing that I know that we can do about that. Okay. All right, so that's sort of given. Now, what is not given is that the way we're using the quantity proxy in our baseline is we're basically we're defining net demand here as the sum of the buys minus the sells. People have used other definitions of this, for instance, where you divide through by the volume, and we have that in the robustness analysis. Does that change things? Yeah, it changes the results, obviously, but it does not change the big picture of what I'm going to tell you. And then another thing that I want to emphasize from the beginning is that the way we have the paper right now, and that we had it from the beginning, is we're going to estimate this VAR 4 times. On the one hand, we're going to use at the money and out of the money options, and then we're going to use call and put options. And some people say, oh, that's kind of weird because all these markets are related, especially if you're interested in market makers, right? The market makers inventory comes from all of these markets, so you should basically, link those and put all of the data together. I have a robustness analysis now that does that. It's not in the paper yet, but I have it here, and that's also not going to make much difference for the main conclusions. The reason that that we did it this way. I'm still not sure whether it's the right way or not, but so we're also interested in, number one, the differences between calls and puts, but also especially the differences between at the money and out of the money options. And it turns out there's really important difference there in terms of what's demand driven and what's supply driven. At least that's what our analysis tells us. All right, so what I'm going to start with is, for me, it's the heart of the paper. It's simply looking at these time series of latent demand and supply. And so I'm going to spend some time on that, and to the extent that I can talk about other things, that's fine. But for me, really, all the intuition of what's going on is in here. So I'm going to show you the time series of latent demand and supply. So there's a lot going on on this slide. So let me sort of elaborate a little bit. So first of all, it's sort of blocked here. This is for at the money calls. So like I said, we're doing it for 4 markets. I'm not showing you the results for the 3 others. Very similar in many ways. So there's a lot of similarities between these markets in terms of latent demand and supply, and I'm going to show you some statistics to corroborate that. But so I'm just focusing on one of them, at the money calls, in the interest of time. And so here's basically the heart of the paper. So we have 2 pictures here. On top, we have net demand and prices. So prices are in what do we call this color? Brown or burnt orange or whatever it is. We have prices, right? Right axis. And on the left, we have net demand. So these are the raw data. These are our price and quantity variables. And then at the bottom is the output from our analysis, the latent supply and latent demand. Demand in red on the right axis, and supply in blue on the left axis. And so now, to some extent, I don't want to over elaborate on this because all you see is 4 lines, which obviously all show a lot of variation. So let's just highlight a couple of important events, first of all, to get some intuition for what's going on. So we're highlighting a number of events here. So these ones here are circled. This is the Russian default, which is way back in the 90s. This is Lehman, which we all know in the financial crisis. This is TALF 2. That's when the federal government put more money in that asset-backed fund. This is the first flash crash, and this is the one that's probably all in our recent memory, which is COVID. Okay, and so we're looking at other events too. I'm going to cover them in a second. But the reason that we're circling these red circles here on these 5 is because they have something in common. And what do they have in common? It is that you can clearly see there that the price here, the brown, you get spikes in price in all of them. Whereas if you look at the quantity, the equilibrium quantity, it's all over the place, and it's not particularly big vis-a-vis other movements in net demand. And then if you go to the latent supply and demand, you can clearly see what's going on here, right? Okay, and this is circled here. These are cases where demand and supply diverge, right? And so what we mean by that is these are clearly periods of heightened uncertainty in the market, crisis periods, if you wish, right? And what's happening in these periods is that the demand for options shifts to the right, and the supply for options shifts to the left. And what happens in those cases? Well, it's very easy to see, right? If you just have demand and supply in your head, price will go up. And what will happen to net demand? Well, it depends on how big the shift in demand versus supply is. And that's exactly what you see here. So, and then you go back, let's just take COVID. That's the most obvious example to look at, right? So if you translate the price effect in COVID and the equilibrium demand in COVID, what you see is here, COVID, you see my cursor? Here, this is the COVID demand. So demand sharply goes up and supply goes down. Meaning in the COVID period, demand, we're going to see that in a minute, demand for options really, increases very strongly, and the market makers, scale back their supply of liquidity. And so to a slightly different extent, quantitatively, the same story applies to these 4 other crises. So that's what we call case 1. We call it the divergent case. Now notice that when I say divergent, I'm talking about supply shifting to the left, demand shifting to the right. Obviously, we can also get the opposite divergence. That almost never happens, at least not in crisis periods. So it's kind of harder to see when you have big moves in price and or quantity. Here's a second case that we sort of identify as happening on a regular basis. And so here we've identified 3 cases: Northern Rock, and New Century, all in the financial crisis. And then the third one is Black Monday. And Black Monday, I believe, is the downgrade of the US federal debt. Okay, so this is what we call a co-decrease, right? So co-decrease, right? What happens here, co-decrease. So let's look, for instance, at Black. Yeah, so the easiest one to see here is Black Monday, right? So what we see with Black Monday is that you see these little inverted triangles here, right? Is that demand goes down, right? And supply goes down. And when that happens, right, what happens? Well, in this case, equilibrium net demand, right here, is going to follow the signs of supply and demand. So in this case, it's going to go down. What's the impact of price? Well, it turns out it's slightly positive here, but the point is it's not very large, right? So this is sort of the opposite case. Instead of a clear effect on price, now you have a clear effect on quantity, right? And the effect on price is much smaller, just because of the way demand and supply moves. And then you probably guessed it, the last case is the opposite, which is a co-increase, right? And there's fewer cases like that. The one that we found, the clearest one, is the second flash crash. So you see here in the second flash crash, what happens is, right, equilibrium net demand goes up. And the reason for that is that right here, latent demand goes up, latent supply goes up, right? And then equilibrium demand goes up. And the effect on prices is also positive, but it's not huge vis-a-vis some other crises. Okay. So what do we learn from this? Again, I could talk about these time series in more detail, but I really don't have time for it. But what it tells me is that there's a lot of information once you have latent demand and supply. There's a lot of information in there that remains hidden in the equilibrium net demand series, right? Okay, so you get some insights from looking at the latent demand and supply that you do not get from the equilibrium series, okay? And then 3 cases when demand and supply diverge, the sign, right, on net demand is ambiguous, but the price effect is unambiguous. When demand and supply co-move, right, it's the opposite. The price impact is ambiguous, and net demand takes on the direction of demand and supply, right? Now, as I already said, I don't have time to get into the other markets, but they're in the paper. At the end, if we have time, I've got tabs here to look at those pictures. And so my summary of those pictures is: are they exactly the same? Of course not. But qualitatively, you arrive at the same conclusion. And in fact, the amount of co-movement between the latent demand in those markets, in those 4 different markets, and the latent supply in those 4 different markets is quite impressive. And so that's exactly what I'm going to try to show you. Rather than look at the pictures, I'm going to show you some descriptive statistics. So I'm going to talk about co-movements in demand and supply, first of all, across these 4 markets. Okay, so at the money, out of the money, calls, puts. So here it is. Okay, so what we have here, this first table is equilibrium net demand. And then the second one here is demand. The third one is supply. Okay, right. I just want to highlight one important thing. What's your prior about the co-movement for, on the one hand, demand and supply across markets? Well, maybe you don't have a clear prior on it, but I would have thought it should probably be a fairly, to a large extent, they should move together. Now, if you look at net demand, the equilibrium net demand, you see that you have some negative signs, and then you have some positive signs, right? Some negative, some positive. Once you go to net demand and net supply, right, you can clearly see that everything's positive. Meaning, right, when the market maker, basically, that's probably the easiest one to understand, right? For the market maker, when you look at supply, right, because of their inventory, right, they're going to scale back or expand their liquidity across these markets, in a consistent way. To me, that's sort of fairly intuitive. So they're either going to reduce their risk or they're going to expand their risk. And then, of course, you can start telling stories about calls versus puts, etc. But to some extent, that makes sense. This is maybe a little bit more surprising. It also turns out that from the demand side, right, once you look at the latent demand, there's a lot of co-movement, okay, between these different markets. Now, please let me remind you that this is by no means built into the analysis, right? So because the analysis proceeds one market at a time. So we're re-estimating the VAR for at the money calls and puts, out of the money calls and puts separately. So there's no way that any restrictions in the VAR could be causing this. All right.
So since I'm in charge, even though there's other questions in the chat that I put off because I thought the answers would be too lengthy, but since I'm in charge, I'll ask my own question.
Okay.
So in column 3, supply, ATM calls and puts, the correlation is 0.14. Given that it's the same market makers supplying calls and puts, isn't that too low?
That's a good question, Neil. Yeah, I've also looked at these numbers and tried to sort of start thinking about which one should be higher than, you know, it's possible. Yeah, it's a good point. Yeah, it's a good point. I mean, you're saying isn't it too low? Not absolutely, but in comparison to some of the other numbers that are bigger, right? So yeah, I don't have a good answer for that as to the differences between these, but there's definitely very legitimate stories that you could tell here as to why some of these should be bigger and why some of them should be smaller. The main thing I take away is that they're all positive, but you're right that you could dig a lot deeper in that. Okay, so okay, this just summarize what I just said. So when you look at equilibrium net demand, you sort of get a mixed message. When you look at demand and supply, the latent demand and supply, you get a very clear message, even though, as Neil says, you know, you might ask yourself some questions about the magnitudes. All right. Now so this was correlations between markets. Now I'm going to talk about correlations within markets between demand and supply. Okay, and so what I want you to look at first here is, this is for the full sample. This is number 1, right? So what we have here now is, here we have demand and here we have supply, and we're going to do it again for all these 4 markets. Now, one thing, this is a technical restriction. The fact that this diagonal is 0, that's because when you use the whole sample, that's something that is basically imposed by the VAR, that this is going to be 0, because those are the two variables structurally in the VAR. Okay, so then the question is, in the full sample, you know, what are these correlations? And so again, you can tell some stories about that, but I don't find them, you know, not too convincing for me at least. What I find more interesting is that now, if you take the estimates for the full sample and you start looking at what these correlations look like in the two most important crisis periods that we have, which is the financial crisis. So what we do here is we basically define the financial crisis as covering a certain period in our sample. I forget exactly what the length of the period is, but it's about 1.5 years or so, I think. And then we define about 8 months or so for the COVID crisis, right? And then we basically recompute these correlations between demand and supply. And so what I find really interesting is, let's just focus on the diagonal. So the diagonal over the whole sample is 0, but then you can clearly see in the crisis periods that diagonal becomes negative here in the financial crisis, and it becomes very large and negative in the COVID crisis. And so what do we basically see is that we see economically very meaningful, right, within market negative demand supply correlation in crisis periods. Right. So basically what's happening in crisis periods, it seems, is that, and so the pictures we looked at tell you that story to some extent already. In crisis periods, what seems to be happening is that very often, at least, demand shifts to the right and supply shifts to the left, right? And so that's the negative correlation. Okay, here's you know, probably the best example to look at that. So what we have here is the same pictures that we looked at before, right? So this is net demand at the top, and then the latent supply and demand at the bottom. But here, sort of, we're looking at the 4-month period or so, I think, in the recent COVID crisis, and you can clearly see the demand in red and the supply in blue. You can clearly see how they diverge. So basically, it's almost like clockwork that every time that demand goes up, supply goes down, and vice versa. Most clearly here, right? Which I believe is March, but I'm not totally sure. Okay. Good. All right. Time flies. So let me try to cover the main points. Like I said, the heart of the paper for me is just to look at latent demand and supply, and just very simply look at the time series and think about these descriptive statistics. But we can do a lot more. So the first thing that we do is we look at the determinants of demand and supply. What does that mean? Well, once I have my time series of demand and supply, now I can regress it on anything that I think might shift demand and supply. And so I don't want to I don't have time, I should say, to talk about individual variables, but so think about all of these variables as follows. So what do we have here? This is the index return. This is realized variance. This is the VIX. This is the skew, kurtosis. This is the VVIX, so kind of like a Ford moment also. This is the TED spread, and this is the CDS spread. So just to summarize, right? RV, VIX, kurtosis, VVIX, TED, and CDS, the more uncertainty in markets, the more nervous markets are, they go up, right? And then RS and skew, right? The more nervosity in markets, the more there's crisis, they go down. And then if you look at it from that perspective and you look at all these variables, all these signs are consistent here for demand. So basically you take your demand shock and you regress it on these variables and you get a very consistent story, which is that, right? So let's take the variance, right? Or the VIX. If there is higher volatility, therefore more uncertainty, right? Then demand shifts to the right. And that also explains these two negative signs. What about supply? Well, again, for supply, follow the similar logic. Now we regress the supply shock on these variables, right? And there you see that for the most part, the signs are opposite to what I just said, right? So you get these negative signs here, except for RS and the skew. And so what that basically means is that when there's a crisis, demand shifts to the right and supply shifts to the left. It's all very consistent with that. Okay. All right, so this is a summary. When risk is high, demand curve shifts right and the supply curve shifts left. Very consistent with what we've seen up till now. And so another way to say the same thing is that on days when the shocks diverge, so when the latent demand and supply shocks diverge, that basically indicates that we're in a high risk environment. Okay, I'm going to go over this very quickly, but it is something that sort of is relevant for some of the questions that we get. The vector autoregression that I've been talking about up till now is a very simple vector autoregression with only two variables in it, right? So price and quantity. And then what I do is I take the latent shocks that come out of it and I regress it on all kinds of variables, all kinds of shifters of demand and supply. And a very natural question to ask yourself is, well, if you believe that those are shifters of demand and supply, right, then why don't you put them in the vector autoregression? And the question is, can we do that? Yes, we can do it, and we've done it, right? So here's one example that we run where we expand the vector autoregression with three of these variables that I just talked about: the change in the VIX, the change in the skew, and the return on the S&P 500. And so now you can re-estimate the system. Now, when you do that, you know, the original vector autoregression is very simple because we just have these sign restrictions here that I indicate. Now here you've got to have to, you basically have a much bigger matrix. The restrictions we build into the matrix is that we put some zeros here. And what those zeros indicate is basically that, right? What that indicates is that those three variables, those three shifters, cannot be impacted by the latent demand and supply shock. So this basically, I think that's a common sense restriction. Apart from that, right, this part of the matrix here basically shows you that all kinds of interdependencies between those variables are possible. So when you re-estimate so I'll be, you know, my honest opinion is that in some ways I prefer the two variable VAR because it's simpler. Here, you know, you got to be careful to include variables that matter because otherwise, you know, my guess is that it's going to affect the precision of your estimates, right? But nevertheless, when you do this, you sort of get a fairly consistent answer, which is that if you put some of these variables in there, and then you look at the latent demand and supply, well, then if you regress them on those variables, that's no longer there, that's taken care of. And then some of the things that remain in the latent supply and demand that comes out of this are things that things like, for instance, liquidity measures such as bid-ask spreads, right? And so basically, once you take care of the fundamentals, such as the VIX or the skew, then what's left is liquidity shocks. Let me sort of, at this point, because I can already see I'm not going to get to some of those frequently asked questions that I mentioned earlier. So a lot of people sort of, ask about this, and they're basically asking questions about, the demand and supply shocks, right? So let me elaborate on that a little bit. So when you specify a VAR, right, with price and quantity, just the simplest VAR I talked about, right? what you're estimating is those epsilons. In the macroeconomics literature, those are called shocks. But you got to be careful because that's just terminology. Basically, if you just have price and quantity in your VAR, those are not sort of shocks in the sense that we usually think of them, but those in financial terms, those are really demand and supply. And so what that means is those epsilons that I showed you earlier, those time series, that basically embodies everything that could shift demand and supply. And sometimes maybe from a microstructure perspective, sometimes we think, when we think about demand and supply shocks, we think of very specific things. And so I want to be very clear about this. What we're identifying here with this approach, those are not necessarily the same type of shocks that you might think of from a microstructure perspective. Basically, what we're identifying is the total demand and the total supply, latent demand and latent supply. And so there's some people think, oh, on the one hand, there's fundamentals, and on the other side, there's shocks. That's not what's going on here. These shocks also include any fundamentals that shift demand and supply, right? And so that's something I think because of the microstructure literature, which has, first of all, worked a lot with vector autoregressions and which has, models of price impact, maybe we're sort of trained to think about it this way, and that's totally fine. It's just that when you use the methodology that we're using here, what comes out of there, right, in the two variable VAR is simply, we call it shock, but it's total demand and total supply. Okay. What else can we do? Well, we can say something about the relative importance of demand and supply in these markets. So this is a very simple story. So again, here I have the full sample on the left, and then I have the financial crisis and the COVID crisis. So this is basically a direct output from a vector autoregression where you can basically check whether demand and or supply are more important by looking at the percentage of the variation that's explained by demand and supply. And so when you get a positive sign here, it basically means that demand is more important than supply. When you get a negative sign, supply is more important than demand. And so interestingly, if you look at it, for at-the-money puts and at-the-money calls, we got a positive sign here for the full sample. For out-of-the-money puts and calls, we get a negative sign. So what that translates into is largely consistent with my intuition or prior, right? The demand is more important at the money, and then supply, inventory, I guess, is more important out of the money. What happens, and this is a very interesting thing, what happens again if you look at not a full sample, but if you look at the crises, right? And I want you to look at number 3 here, especially the COVID crisis, just because it seems to be so much, the effects there seem to be so much clearer than in the financial crisis. You see that in the COVID crisis, this number here goes from 9 to 41. This one goes from 14 to 70. This goes from negative to 16, and this goes from -6 to -2. In other words, in COVID, what really becomes very important to explain the data is demand, right? So whatever happens in option markets in COVID, it's to a large extent, it seems at least from these data, is a demand-driven story. Okay. All right, so this is what I just said. All right, we also present results on predictive regressions. I'm going to go over that very quickly in the interest of time. These predictive regressions are to some extent inspired by a really nice paper by Sophie Nie and Chen and Jocelyn, who it's actually probably the most closely related paper to what we do, because they use similar data, and they also identify these different regimes in the demand data. And so what Chen, Jocelyn, and Nie show in their paper is that once you sort of extract certain things from those data, which they do in a very different way than we do, you can use that to predict future returns, right? So what we do in the paper is we try to use the latent demand and supply to predict what you see here, is to predict the future S&P 500 return. And we also have results on predicting option returns, right? So what we have here is it's kind of a busy table. This is out of the money calls on the left, and this is at the money calls. And so there's a difference between out of the money and at the money, right? And the difference comes from the fact, again, that at the money is more demand driven and out of the money is more supply driven. So what do we do? So first you run univariate regressions. And so long story short, the signs of latent demand and latent supply here are consistent with intuition. So what does that mean? Just to give one example, latent demand enters with a positive sign. So it means that when latent demand goes up, the future return goes up. And the reason is because latent demand going up means a shift to the right is in a crisis period. So that means there's more risk in the market, so you have to get a higher return. So this negative sign is also consistent with that. This sign is consistent with what people find in the literature. And this sign, I think, also makes sense, which is higher price, basically. A spike in price basically signals more risk and therefore higher future return. I think that's intuitive. So then we augment these univariate regressions with some of the other information that we have. And so what we do is we create this dummy. And this dummy is one in periods where demand and supply diverge. So those is basically in the crisis period. And you see here that, one thing I should have mentioned is that in terms of predictive ability here, the variable that really matters is not the demand variable, it's basically the price variable. It's not the net demand, it's the price. That actually predicts the best. What we show is that if you use, in the case of the out of the money options, if you use the supply, the latent supply, and you interact it with that dummy, you can improve that predictive ability, modestly, right?
So there's a simple question that I should ask here. So, yeah. And the question is the forecast regression out of sample?
Excellent question, and I should have mentioned that. And this is out of sample, meaning recursive, right? So we do exactly what you have in mind, which is that we re-estimate the VAR, and we basically always keep one shock from each re-estimated VAR, and then so that we have a genuine out of sample predictive regression. Thank you. That's a great point. I should have mentioned that. So what you see is that here in the case of the out of the money options, you can basically out of the money call options, it's your demand. It's your supply variable that helps you a little bit to improve your forecast, whereas in the at the money market, it is the demand variable. Again, consistent with the intuition that we had before. All right, I'm rapidly running out of time. Price elasticities. Okay, very quickly. So I cannot talk about price elasticities without contrasting, what we do a little bit with the existing literature. So what I have here is I have slopes and I have elasticities. And so the slopes are useful to compare with what you would do if you run an OLS regression, right? So if you run an OLS regression, right, you're basically using, right, the equilibrium net demand. And so I think that these estimates that we get here for OLS regressions in these four markets are pretty consistent with what people find in the literature. And what do people find in the literature? One thing is that these numbers are fairly small. And second is they can take on either sign. They're not always positive. And the reason that they're not always positive is it really depends on whether demand is moving around a lot more in your sample or whether supply is moving around a lot more in your sample, right? Okay, and that's exactly what we're trying to avoid. Okay, so these OLS estimates here for the slopes are our benchmark. So what do we see? What we see is that when you apply our approach, you get slopes. So what you can do is for the supply here, you can directly compare this. So this is a posterior mean, right, with a very wide confidence interval because we have a non-informative prior. But you can directly compare this number with this number. You can directly compare this number with this number, etc. And so it's a very simple conclusion. Those slopes are a lot larger. Okay, and so we believe that one possible interpretation, let me be careful here, is that it really indicates that whatever you get in terms of price impact out of these OLS regression is severely downwardly biased, which I think that's not a controversial statement. I think we know that. We just, it's not easy to fix it, but so basically we get much larger slopes. But so some interesting thing here, which is that the literature, in a way, what I realize is the literature always, reports these slopes, but even when you get these much larger slopes that we get and you translate it into elasticities, even those much larger slopes still result in elasticities that are fairly large. So what we can see here is that all of these elasticities are actually above 1, and the same happens when you look at the demand elasticities, right? And then another interesting thing is that the at the money elasticities are higher than the out of the money elasticities for the supply. I don't know about you, but that's exactly, again, consistent with my prior. Okay. Okay. So now, I should mention this. So once you get these elasticities, again, when you look at these numbers, if you want, you can go to the Cohen-Yogo type of analysis and you can compare it with their numbers, right? And so what they get, my understanding of that literature is that the elasticities that they get it depends on the securities, but some of the elasticities, especially these numbers like 8 here, are not totally out of line with some of the numbers that they get. All right. Okay. By the way, yeah, one thing I don't have here is that even so the statement earlier where I said that market makers provide ample liquidity, that means these elasticities are fairly large, right? And if you repeat this analysis only with the crisis periods, then you still get elasticities that are smaller than these numbers, but are still above 1. So they provide still substantial liquidity in crises. I got a couple minutes left. I'm going to run through additional analysis, and then I'm going to talk a little bit about those frequently asked questions. So additional analysis, some of you have probably all kinds of questions about robustness analysis. So the analysis that I showed you, I didn't mention it, but it's basically for the most liquid option. So it's 1 month maturity. We have results in the paper for different maturities, qualitatively similar. Like I said, you can do different quantity proxies. Does that affect the results? Yes, it does, but not the big picture of, in terms of, is demand more important than supply? Can we forecast, etc.? All of those results remain relatively robust. Alternative price proxies, again, those results are in the paper. You can impose some restrictions on the supply and the demand curve. Again, I'm going to have to refer you to the paper for that. And then we also have a comparison with the results of Chen et al., which, like I said, is an interesting paper. And we can replicate some of their results, and we can put our results in perspective given theirs. I briefly want to talk maybe a little bit more about what else can you do. To the best of my knowledge, is this technique that we're using perfect? Of course not. Nothing's perfect, and can something go wrong? Of course, a lot of things can go wrong, and we'll probably find out more about it as we go along. But the thing I want to emphasize is that there's not that many alternatives. I think the 2 alternative approaches to deal with this OLS problem in the literature are very well known. Dimitri has used one of them in one of his papers, which is instrumental variables. And so what we do in the paper is we replicate with our data what happens if you use instrumental variables. And then the other approach is something that people sometimes refer to as the Rigobon approach. And so the Rigobon approach is what's used in the Chen et al. Paper. And it's also a very intuitive approach where you basically, you do exactly what we're doing. You try to sort of identify different, you try to identify periods where demand and supply sort of interact in different ways through volatility regimes. So the intuition is very simple. Like what I said, in crisis, we have demand shifting to the right and supply shifting to the left. What do you get? You get a big impact on price. So you get a lot of volatility. And that's exactly what this approach does, is because they basically try to identify these regimes based on volatility regimes. So again, we replicate, we basically implement these approaches, and long story short, we get results for our data that are very different from those elasticities that I just showed you. And again, I'm gonna have to refer you to the paper for the details. Very briefly, in the 2 minutes that I have left, a discussion of some of these issues. Okay, so these are questions that we get a lot, especially the first 2 I want to emphasize. So some people ask, and maybe this was behind one of the questions that we had earlier, are these findings, especially the findings about demand and supply in crisis, are they mechanical through the sign restrictions? And so there, I hope I can be very clear. In some sense, yes, they are mechanical. They're mechanical given the data. If you look in a crisis and you see that something happens to price, namely price goes up, and at the same time, right, quantity doesn't do much, well, then given these sign restrictions, which I think we can all agree on, it's Econ 101, then yes, there's only one conclusion possible, right? But so is that mechanical? Well, that's a sort of a choice of words. Maybe it is, but that's not a bad thing necessarily. That's just basically you're combining the data with economic logic. So I don't necessarily see the problem with that. And then the second important issue that people one other really important issue that people bring up, I've already mentioned very briefly because I didn't think I would get here, is that people get confused because they say, well, you got these demand and supply shocks, and they seem to be correlated with fundamentals, with the VIX, with the skew, etc. And so the answer there is, again, it's a choice of words. Maybe it's a poor choice of words on our part. We have to call this shocks because it's in a VAR, but they're not maybe the shocks that you're thinking of. They basically are latent demand and supply, and so they incorporate all kinds of things, including fundamentals. Put call parity. Some people are worried because we have these 4 markets and we don't impose put call parity. Here in gray, you see what happens when you impose put call parity with the ATM results. So here, this basically is ATM results, right? Where you don't use a put sample and a call sample, you use all of them and you impose put call parity and look at the elasticities, right? It's very similar to what we have here. And here for supply, right? They get a little bit bigger, but pretty consistent.
It's my duty to tell you we're at 1:31. We're at 61 minutes.
We are done, and
right.
I was going to conclude, but I'm out of time, and all of this I've already emphasized. Thank you, Neil.
All right, so Kris, thanks very much. There was an active discussion that Paola in the chat that Paola was participating in, and I didn't interrupt you with it because it seemed like a serious discussion and it would take too much time for you to answer all the questions. But I think Paola answered some of the questions in the chat. So rather than read the chat to Kris, I guess I'll say if Paola didn't answer your question, or if you have another question you'd like to ask, now is the time to unmute yourself and shout it out.
And thank you, Paola, for for doing all that, because I had my hands full already. Yeah, go ahead, Stylianos.
Okay, first of all, let me put it this way. I started the rather negative opinion of this research. I changed my mind, actually. Very, very nice. I like several of the steps. I like, for instance, the separation of the ATM and OTM, and I like the separation of calls and puts, which is not done very, very often. And to a point of information, I haven't done anything with SPX options. We're doing it right now, but I have looked in detail SPXW options, which I've sent also to this for presentations. I'll send the revised version. And I have noticed very clearly the ATM and OTM separation, and of course the huge difference between calls and puts in terms of volume. Okay, very, very simply. And I have reasons to believe that SPX are similar. My main objection is that the supply side is emphatically not competitive, because there is exactly one designated market maker. There are no market makers, there's market maker. There are also broker-dealers that have a right to compete with them. But the competition is not equal in the sense that the market maker, the DPM, is protected, it has a minimum share, and also has information advantages, very large. So it's at best a tight oligopoly, at worst, if you like, it's a monopoly. So this would change your results.
This will? Or is that question, Stelios? Or
yeah, it's a question.
Okay, good. Yeah, so there's a lot of people in this crowd who know a lot more about the institutional setup of this market, and so I'm gonna let them jump in, or better, I'm gonna ask them to jump in in case I say something wrong. But my understanding, I think, is consistent with yours, in the sense that I think of this market on the supply side as consisting of a relatively small number of very large players, right? And then indeed, you can probably characterize that market structure as oligopolistic. Let's take the extreme example of your reasoning. Let's say that there is a monopolist here. Yeah. And again, I have to think about this more, and I thank you, because I hadn't thought about it at all, whether it would change anything. So maybe I should have. But my first reaction, sometimes wrong, my first reaction is that even if there was a monopolist here, I'm not sure it would invalidate our empirical approach. I think what I would expect is, obviously, if I repeated this analysis with a monopolist, with a market that was a monopoly, and then I compared it with another market that is an oligopoly, or where there's more competition, I would expect to find different elasticities. But that's what I would expect to be the main conclusion. That doesn't mean that you cannot feed the data through this tool. That's my first reaction. I don't know if that makes sense.
Well, all I can say is it will affect probably the econometrics. It has to affect because you have different relations.
No, that's where I disagree a little bit still. Is again, first reaction. I don't agree because the econometrics just rely on, the heart of the econometrics just relies on the sign restrictions. That's not going to change. And then the implementation of the econometrics is much more complex, and that relies on the priors, etc. And that can create problems. But I think those problems can occur regardless of the market structure. That's what I'm trying to say. But unless there's something I'm missing.
Well, the most important, of course, is when there is competition, there is an intermediated market, very clearly. Okay, there are intermediation there. The market makers are intermediaries. Well, when there are and the intermediaries, there is a bid and an ask price. That's where it's determined. The bid and ask price should have been endogenized in this calculation, especially if there is a market power. That's all I'm saying. That's at least what we're trying to do with the SPXW, okay? And that's quite interesting, I can tell you.
Okay. I'm going to think about it more. That's the only reaction I have. That's my first reaction, but I'm going to think about it more.
Apart from that, it's a good, I have no comments. It's simply, as a macro, it's excellent. The intermediate market needs modeling, needs more work. That's all I'm saying.
Thank you, Stelios. Any other questions?
Other questions? Or did Paola do a great job answering?
I was just going to say, Paola took care of everything. Paola, they don't dare ask questions anymore.
Yeah, no, what I was going to say regarding the designated market makers is that SIBO, from what I know, they designate 2 per week or per period. I don't remember if it's per week or per month. So it's not monopolistic from that point, from that sense.
But then there's others, right, Aurelio? There's other
yeah, totally. Yeah. I'm just saying SIBO. That, right? So yeah, I'm just saying SIBO. So
well, I beg to differ. It states very clearly it's one class for the SPX class and one for the SPXW, the DPM, designated liquidity provider. That's what they say it very clearly. I'll send you the reference.
Sounds good. Björn is actually raising a hand, a physical hand I saw.
Yeah, I couldn't find the virtual one. I have like basic questions. The first one is I'm looking at the VAR, and I don't quite understand exactly what you have a dependent variable, which is prices and quantities, which are dependent on their own lags. But the structure is sort of from.
You're breaking up a little bit for me. I don't know for others, but I don't hear everything you say.
Okay.
You said about the structure of the VAR, yeah, and then I lost you.
Yeah, the first element of VAR is normally we think of financial market prices as having a random walk component, but if you think about any kind of standard option pricing model, with time varying coefficients, right? So that model is sort of not nested within equations 1 and 2. It will lead me to think like, so I wonder where identification is coming from if I can't nest like a Black-Scholes type of price dynamic or and the other thing, the other question, and this is a question because I don't understand exactly where the identification of market makers as being suppliers, as opposed to having all participants in the market just be having demand functions that slope in such a way that market clears when there's when one person is selling to another person in such a way that there's a zero aggregate at all times.
Mm-hmm. Yeah. So two questions, two very different questions. So let me deal with the second one first, which I think is hopefully a little bit easier. So we're starting from from this open close CBOE data where what you basically have is you have this distinction between market makers and non-market makers, and obviously, like I said, it's pretty clear that within the non-market makers there are very large players that are also providing liquidity. So and maybe part of your question is motivated by what happens in this demand literature that I mentioned, the Koyan literature. It's completely different, right? So there basically you observe equilibrium quantities and then you infer the elasticities from there. So somebody will probably jump on me for this, but the way I understand what's going on in that literature is that basically demand is negative supply, right? Because you're basically, everybody can be a demander or a supplier. So to me, given that you're only considering demand, that's the only explanation, right? So could you do something? So to me, it seems intuitively, and I haven't thought about this enough, but intuitively, it seems that this data that you use here, CBOE, subject to the criticism that it's not perfect, it should help you to some extent with identification, right? Because you get one party that's a more natural supplier and the other side is not. How would you go about ignoring that? And go ahead.
Actually, I tend to disagree. Sell options, I'm a supplier. No, and I sell option as a retail trader. I could sell them all day long, right?
Yeah. No, it's yeah. Yeah, I've thought about it. It's a great question, and so how would you go? So another way to put your question is, could you take Ralph's apparatus and sort of apply it to option data in a similar way, and I guess then ignoring the CBOE open close data to some extent. Maybe that's what you're asking, and I haven't thought enough about that, but I guess the answer is yes, because you can. They're basically applying it to different markets, and I don't know if you need any more specific identifiers for it, because basically you're just inverting it back from equilibrium demand that you're observing in the market. But the thing is here, the two components add up to zero. It's zero net supply by definition, right? So yeah. So yeah, I don't know. It's good to think about. Yeah. So your other question is much harder. You're basically saying, I think it's much harder. You're basically saying how to think about something like a Black-Scholes model within the context of the VAR, where you would basically, I think there's something in this literature that could help with that. So we don't do this, but in the macroeconomics literature, we just restrict the signs contemporaneously. In the macro literature, what people like Ulik and many others have done is that you also additionally put restrictions on the lags. And so I think what you're getting at, you could do by putting restrictions on the lags. So now, come to think of it, something like that should be possible.
Let me ask about the lags, because I don't know, I understand. Like, if I go back to the central basic model of random walk in finance, that first B1 element of the VAR is going to be some of the elements. Nothing is going to predict the price above.
Yeah.
It's a random walk. So
that's exactly what I mean. That you would start putting restrictions on B1 and B2 and whatever how many lags you and I think you can come to think of it. If you look into that literature, probably you could try to do that. We haven't, just for clarity, but I think that could be possible to impose those restrictions.
So just a clarifying question then. So you do estimate all these B matrices, the various lags up to some lag length L.
Yeah, which in our case, in the baseline restriction with the BIC, we select 2 lags, I think.
Okay.
Correct.
Related, I mean, and in this VR specification is to say, okay, well, I can allow for other things to impact prices and quantity directly in the VAR as well.
Yeah. So that, correct. So that's, Björn, that's what I briefly talked about it, but I talked about so many things.
I missed that part. Okay.
It's okay. So that's what you would do with a specification like this.
Yeah, but you want to make those coefficients not zero, to be fair.
Which ones?
Well,
These
the
here?
ones which are zero, right?
No, I'm not sure about that, Dimitri. So what are we? I mean, you could just for clarity, but do you want to is the question, right? So what are we basically saying here by imposing these zeros here, right? What we're basically saying is that let's see. So let's see here. So you're basically saying that the latent demand and supply, right? So you have the same sign restrictions as before. And then apart from that, you're basically saying that latent demand and supply affect equilibrium, price, and quantity, but do not affect the other variables that you use as shifters. I think that's a very reasonable restriction. I don't think, Paola, correct me if I'm wrong, I don't think we need to impose those zero restrictions to be able to estimate this. But I do think they're reasonable restrictions. And I cannot remember if we estimated it without the restrictions, to be honest.
So I don't know if I can jump in just to say, like, so basically in this matrix, every column needs to be different in order to identify the shocks. Otherwise, you cannot identify the economic shocks. So, and the point is that we restrict the supply and demand shocks to identify them, but we do not restrict the risk shocks. So basically, the first 2 columns identify what is a supply shock and what is a demand shock. And the last 3 columns, identify the risk shocks, which actually are not identified as different. So the last 3 columns, are just risk shocks. And they are not restricted. So basically, risk can impact price, quantity, and risk, and all the risk variables. But demand and supply shocks can only impact price and quantity and not the risk factors. So this is necessary because if you have columns that have the same sign, so then you don't know, you can have a shock that is mimicking another shock, and then you cannot, identify that anymore. Yeah, that's just the explanation of the zeros.
So I just want to add a little bit to that. So technically, we do not need all of those zeros to identify the shock, but I think it's a reasonable assumptions to have as well. But theoretically speaking, we don't need those zeros to identify the supply and demand shock. What it could do is actually shrink down because it is set identified. So with these restrictions, if we believe that they are reasonable to understand, it helps us narrow down the set that we will receive, and therefore might have a relatively a little bit more precise estimation.
Yeah, nice. Then you guys can go and estimate it without zeros and compare it to zeros. Would be a nice validation for the methodology.
Yeah, that's good to me.
Good. I'll seize this opportunity to jump in and thank everyone who's still there. We can continue having a chat afterwards, but I just wanted to thank the audience for being here, and I wish that we'll see as many of you in 2 weeks, October 19th, for Pasquale della Corte, who's going to talk about FX option volume. In the meantime, have a great rest of the day, and to those of you who still want to torture Kris, I mean, we can stay around until he decides to have an internet interruption of some sort. Ciao, everyone.
All right.